All right, so this is the recording for the next test, guys. And so you want to be practicing all the questions, all the blue questions that we covered today. But there's going to be certain blue questions that are going to have a star beside them. And that's ones I'm going to be asking you guys to do. And so maybe what we'll do, since we don't have two teams of two, we'll just kind of have it as a challenge and see how many you guys can get out of 28. Okay, because there's 28 in all, which kind of reminds me as well, March 28th is my birthday coming up. So there you go. You can buy me something if you like. I'm just kidding. Totally kidding. Anyways. Okay, so let's get started, guys. So we got a picture here, and it says you have to solve this problem by yourself. You can't call tech support. Don't you wish you could call tech support? Yours is May 14th. Good stuff. Right on. Okay, so guys, first of all, what we're going to go over is we're going to go over changing between fractions, decimals, and percents. Okay? So that's normally the direction we go in. We go from a fraction to a decimal to a percent. And you can see here we've got 4/5, and then we change it into a decimal. We divide the 4 by the 5. That gives us this decimal of 0.8. So here's the math in blue. And then to go from the decimal to a percent, we multiply by 100, right? So that's the basic math we're going to be doing in the next couple questions. So the first question we have here, it says rename each percent as a fraction. So we have to change 24% into some fraction that has 50 on the bottom. So let's think about how we're going to do that. Well, the first thing, we always remember that the word percent means out of 100, right? So we're going to change this into, first of all, a fraction with 100 on the bottom. So all we do to do that is divide 24 by 100. That's pretty easy, right? Now all we need to do is change 24 over 100 to some fraction over 50, because that's what the question asked for, right? Okay, so all we need to do is if we have 24 over 100 and we want to make it some fraction over 50, since 100 is twice as big, we're going to divide 24 by 2. And when we do that, we can see on the next screen, 24 divided by 2 is 12, 100 divided by 2 is 50. So we've got our answer. Okay? So here's a question for you guys. This is where you guys need to see if you can answer it. Because again, I said anyone with a star is when you can answer. So for this question here, 75% equals something over 20. What do you think the first step would be based on the example we just looked at? What's the first thing we're going to do? Okay. Any other ideas? Remember, it's a percent, right? And what does the word percent mean? Anyone? Okay, remember, percent always means divide by 100, right? So that's the first thing we're going to do. We're going to divide it by 100. Okay, so once we get a fraction divided by 100, what are we going to do then to that fraction to end up with this here? Okay, so you're saying, okay, so what are we doing with the 5? Rick, I'm not sure if I'm going to be able, I'm just going to call you Rick. So Rick, what do we do with the 5? I think you got the right idea. 5's involved, but what are we doing with that 5? We've got a fraction with 100 on the bottom. 25% of 20 is 5. Okay, so what we're doing then is we're dividing 100 by 5 to get the 20, right? And so if we look on the next screen, we can see what we're doing to change this fraction of 75 over 100 into some fraction that has 20 on the bottom. We divide 100 by 5 to get 20 on the bottom, so we have to do the same to the top. So we're going to have to divide the 75 by 5, and we get 15 over 20. So just like Rick said, good stuff. So we'll give that one, well, since we don't have two teams, you guys get that one. So there's 1 point. Good stuff. Right on. I'm just going to check real quick if that other person is online. If not, we'll just carry on. Okay. So, next question. This one says, in Julia's class, 36% of the students speak more than one language. Write the number of students who speak more than one language as a fraction in lowest terms. Okay, so here's what we have to do then. First, we have to change the percent into a fraction with 100 on the bottom. Okay, we know how to do that. Then we change that fraction into a fraction in lowest terms. Okay, so first of all, we've got our 36%. We make it 36 over 100. That's the first step. Then we make that into a fraction in lowest terms. So we have to divide the largest number that we can into both 36 and 100. Okay, yeah, go ahead. I don't know. Some of these are questions you've done before in homework, so this is kind of a review. That's probably why. Okay? You're on 24? Sorry, what do you mean? Okay. Yeah, so probably you covered this one. Alrighty? But we're just reviewing it. So what we need to do then to change 36 over 100 into some fraction in lowest terms, we want to find the largest number that divides into both top and bottom, right? So the largest number is 4. And if we didn't know it was 4, we could try dividing 2 into top and bottom, and then we just keep dividing until we can't divide anymore, right? Okay, so 9 over 25, that's the fraction in lowest terms. Okay, so is everyone cool with that? Okay, good stuff. So we got another question. It says rename each decimal as a fraction. So we have 0.34, and we need to change it into a fraction that has 50 on the bottom. So before we can get into a fraction with 50 on the bottom, we need to change it into another sort of fraction. The way we decide what we divide it by, if we had, say, 0.3 and we had to change it into a fraction, we would say there's one number after the decimal, right? So because there's 1 after the decimal, we divide by 10, because this is tens, right? Just one digit. If there's 2 numbers after the decimal, sorry, that's hundreds, so we would divide by 100, okay? So 0.45 would be 45 over 100. Okay, so we're going to have to divide this by 100 because there's 2 digits. That's a hard word to say sometimes. Okay, so we make it 34 over 100, so that's our first step. But then we can see that in the question we have to actually make it into a fraction over 50. So we know we have to divide 2 into top and bottom, right? So I'm just showing that here. 2 into top and bottom, and we end up with 17 over 50. All right? So let's go to the next one. This is similar type question. Okay, so here's a question for you. This one has a star again. So what's the denominator going to be for the fraction? Based on this decimal here. What do you think? Good, okay. You got that one, another point, good stuff. And so next one, what do we get as a fraction with 5 on the bottom? After we have, like Super Toad says, we're going to divide 2 by 10, then what do we get with the fraction over 5? What number is going to be over 5? If we have 2 over 10, we're going to get what over 5? Anyone? I know you know this, guys. 2 over 10 equals what over 5? Who's going to get it first? Right on. Super Toad gets it. Super Toad to the rescue. All right. Okay, so here we go. And this is just showing the math we did. We made it 2 over 10. We made it 1 over 5. Not too bad. 1001 equals 9. Okay, so next question here. Complete each statement using a less than sign, greater than sign, or equal. Okay, so basically we're comparing 2 different types of numbers, a decimal to a percent. Okay, so you need to either change the decimal into a percent or the percent into a decimal. Okay, so I got a question for you guys. Which number is easier to change? Is it easier to change this decimal into a percent or this percent into a decimal? What do you think? Same? Okay. Well, I guess it could be the same, and I'll give you the points for that, because depending on how comfortable you are with this kind of stuff, for me it would be a little bit easier going from the decimal to the percent because you just multiply by 100, whereas Going this direction, you might have to divide 30 by 100 and then take that decimal and multiply it. Sorry, what am I saying? Yeah, okay, it's pretty much the same. For me personally, it's a little bit easier going 0.3 times 100. But I can see what you're saying. It's both the same. Okay, so some of these it'll be a little more clear. Okay, so if we multiply this 0.3 by 100, we get 30%. That's right, you can just move the decimal, can't you? If you've got 30%, you could just move the decimal one time and then another time, because you know it's always having to do with the hundreds. You're moving it 2 to the left, and now you get 0.3. So that's why I was kind of saying, yeah, I could see where you're coming from. Okay, so it's not really clear which is the easiest to change. What is clear is that since we made 0.3 into 30%, we would put equals, right? So these two things are just different ways of saying the same number. So when it's asking us which of these three things we put in here, we're going to put an equal sign, right? Okay, let's check out the next one. Next one here, which one do you think is easier to change? And I think in this situation it's a little more clear. Okay, maybe I lean back for a sec. So which one of these two is easiest to change, left one or right one? Left? Okay, any other votes? Left? Okay. So, but see, if you want to change 0.45 into a fraction, you're going to have to make it into 45 over 100, right? And then you don't know whether 45 over 100 is greater than 7 over 45. Whereas if you do the 7 over 45 and you change that, you can change it into a decimal, and then you can compare that decimal with the 0.45. Does that make sense, guys? Does that make sense, Rick? Okay, so you just divide 7 by 45, and then you'll get a decimal. You can compare the two decimals, right? Okay, so if we do that, we change 7 over divided by 45, we get 0.16, and now you can see if I write that decimal below it, we would put 0.45 is greater than, okay, so we're going to put the greater than sign. It's greater than 0.16. Okay, so we'll go on to the next one. Am I talking, does it sound like chipmunk to everyone? Okay. Maybe if I talk fast, maybe it does that. Okay, so I'll show you one more, guys. So this here, when you compare these two, I'm not going to ask you which one's better to do, but if we change this fraction here into a decimal, we change 3 divided by 5, we put it in on our calculator, and we get 0.6, right? And then we can multiply 0.6 by 100, we get 60%. So if I write that 60% under the fraction that we had, we can see that 60% is greater than 40%. Okay, so we're going to write the greater than sign. Okay. All right, I got something interesting to share here. So what I wrote here is that I said, isn't it amazing how some of the things that are most important to us in the world are things that we can't even see, right? Okay, so, you know, just a month ago, tons of people gave out Valentine's cards. You know, and what did they give them for? For love, of course, right? So, yeah, yuck, eh? But here's the thing to think about, right? So is love important even if we can't see it? Of course it is, right? And it's the same thing with God, right? You know, we can't see God, but He's there just the same. And the Bible teaches that everything we see in the world, what's visible, came from God who's invisible, right? There's a verse in the Bible, I don't know if you guys have heard it, it says, in Him we live and move and have our being, right? Okay, so He's supporting everything in this earth. So, that also kind of brings us to the topic of air. So here's the question, is air important? Okay. Yeah, you learned that verse. Good verse, eh? So, okay, so air is important, of course, right? You know, just try holding your breath for a minute and you'll find out if it's important, right? So, all that is just kind of introducing us to this question. It's about air. All right, so the air you breathe is 20 parts oxygen, 80 parts other gases. So the question we have, what percent of the air is oxygen? That's part A. Part B, what percent of the air is made up of other gases? Okay, so first we're just focusing on part A. So what percent of the air is oxygen? So the question I have for you guys is if we take the numbers that we have here, what kind of fraction can we make out of them? Okay, so you guys are saying 20%. Okay, so we're going to get there in just a second if you guys are right. But first I want to ask you guys, what type of fraction... Okay, I gave you the answer. The question was, what type of number can you make out of the numbers that you have? And that was a fraction. Okay, so that's what I was looking for in this blank here. All right, so once you make the fraction, we'll go on to the next one here. Next question, what's the denominator going to be out of since we're looking at the total amount of air? Okay. It's the total amount of air. We have 20 parts oxygen, 80 parts other gases. What's the total number represent? If we had a fraction. It's going to be 20 parts oxygen, it's going to be 20 parts out of how much? If the how much stands for the total parts? What do you think? That's right, it's going to be 20 over 100. Good stuff. All right, so I just wrote down another mark for you guys. Cool. So the denominator's got to be 100 since we're looking at the total amount of air. And next thing here says, then we can divide the number above and make this number into a, okay, so we're going to make a fraction into what kind of number if we divide? Anyone else? We divide the top of the fraction into the bottom, what kind of number can we get from that? What do you think, Echo? You got a fraction, divide the top by the bottom, what kind of number does that give you? I know you guys know this. Okay, decimal, right? Okay, let's see if you can get the next one. So you take a decimal, you multiply by 100, what do you get? Yeah, I know. We shall ignore it. What do you think, Echo? If you've got a decimal and you multiply by 100, what kind of number does that change into? I'm sorry, guys. I'm going to quickly turn that off so that's not distracting you. Okay, so decimal multiplied by 100 gives a percent, right? You guys know that. I know you guys know that. Okay, so decimal by 100 gives you a percent. So here we go then. This is just kind of a review of what we've gone over, right? Right on. So we said that we're going to make it into a fraction. And we said it's going to be out of 100, 20 parts oxygen out of 100 total parts, right? Then we took that 20 over 100, we made it into a decimal, and we took that decimal and made it into a percent by multiplying by 100. Okay, so in other words, like you guys said from the very beginning, you guys were able to predict way ahead, air is 20% oxygen. So, with that in mind, part B, what percent of the air is made up of other gases? So to get that, what percent of the air is made up of other gases, what type of math do you think we have to do to find out what the percent of the other gases is? If oxygen is 20%, what percent is the other percent of gases? right on. You guys both got it, 80%. Right on. I'm going to give you another mark for that. And so, obviously 100 minus 20, right? That's too easy. Okay, let's get to the more challenging stuff for you guys, since you guys are so smart. And I mean that. What percent of the air is made up of other gases? Okay, so 100 minus 20, we got that there. Okay, so here's another question for you guys. This is kind of a thinking type question. How do you know, without doing any calculating, that the percent for 7 out of 25 is less than the percent of 7 out of 20? What do you think? Okay. Yeah. Good. So if you had a piece of pie and you divide it into pieces, you would want 7 pieces out of 20 instead of 7 out of 25. That's a good way of thinking of it. Yeah. Good. Or another way of thinking of it is that if you divide, you want to divide by a smaller number, right? Because the larger the number you divide by, the smaller the answer you get, right? Okay, that's good. You guys got some good ideas there. So, we're going to talk at this point, you want a bigger piece of pie. What kind of pie do you guys like anyways? For me, it's got to be like banana cream pie, or chocolate pie is good too. Chocolate pie is good. Peach pie? The entire pie. Pumpkin? Yeah? With whipped cream, right? Gotta have the whipped cream. How about you, Rick? Rick likes the entire pie. Pumpkin, but without the pump. Without the kin. Ooh, that sounds like a fancy one, Super Toad. That one is, I don't know what would happen if you mixed all that stuff together. Some stuff doesn't taste as good when you mix it all together. But if you could eat all those separately, that would be awesome. Okay, so guys, I'm going to just talk a little bit about what a benchmark is. Okay, so benchmarks are certain percents we can use to help us estimate other percents. So if you look at this diagram here, it's a really good one to focus on. It just gives you an idea of, for instance, 75% is 3/4, right? So that's like this amount here. And it's just good to really know what these different percentages are in fractions. So 66 2/3%, that's 2/3. 50% is 1/2, right? 33 1/3% is 1/3. 25% is 1/4. Okay, so we're just going to use those benchmarks, as they call them, to help us do some estimating here. So who can tell me what you think 9% of 27 is, approximately? What do you think it is? Anybody brave? 9% of 27. Use one of these benchmarks here. What's 9% close to? Which one of these benchmarks here would 9% be close to? What's a percent that's close to 9%? That's going to help you figure out approximately what that percent of 27 is. Okay, so you say it's going to be around 2. The answer is going to be around 2. Did you mean 10%, Super Toad? Yep, perfect. So 10% of 27, that's 1/10 of it, right? So would you agree that's around 2.7? So it's going to be a little less than 2.7 because it's 9%. So maybe 2.5 or something like that, right? Okay. How about 32% of 62? Any guesses on that? Think about what, okay, now it's 32%. Which one of the fractions is that going to be close to? What do you think, Rick? 3 goes on forever? So what did you mean by that, Rick? So 32%, which one of these fractions is it close to, guys? Is it close to 2/3? 1/5? Okay, I see what you're saying. So it's close to 1/3, right? So what do you think approximately 1/3 of 62 is? Think about 1/3 of 60. If it's 1/3 of 60, how much is that? Okay, so it's going to be somewhere around 20. Good job, right? So B is going to be around 20, somewhere around 20. How about C? What do you think C is going to be? 76%. What percent is that close to? Okay, it's close to 75. Good. And what fraction is 75? Saw Gecko was typing something there. Okay. 75 over 100, or 3/4, about 3/4, right? So if we think about 3/4 of 25, we may not be able to get 3/4 of 25, but if we think of 24, we can divide 24 into 4 pieces, right? And each one of those pieces is 6, so 3/4 is like 3 of those pieces of 6, so 3 times 6 is 18. Okay, so around 76% of 25 would be somewhere around 18. Okay, so that's just to give you an idea of how you can use those benchmark percentages to help you estimate. So, okay, you guys like amusement parks? Probably kind of a no-brainer, right? Who doesn't like amusement parks? My kids went to Fantasyland or Galaxyland for my son's birthday. You don't like them? Well, I don't like the spinny rides. That's one thing I don't really like. And this ride would be kind of borderline because it's kind of makes you dizzy. Yeah, I'm sort of afraid of heights actually too. Although I will fly in a plane and I'll go on roller coasters, but I just don't. The movies with you know, they got a lot of suspenseful music and somebody hanging off a cliff. That stuff kind of freaks me out a little bit. So, anyways, we got a picture of a roller coaster, right? So here's a question: on Monday at the Pacific National Exhibition, ooh, that will be fun. Okay, Pacific National Exhibition. That's in BC, right? So there were 5 children for every 3 adults. On Tuesday, there were 6 children for every 4 adults. So the question is, on which day did a greater percent of children attend? So the question I have for you guys, what steps will we need to change the numbers that were given in the question into a percent? Any idea? You won't tell, then I can't give you marks. Okay, well right now we can make a fraction, right? Okay. We can make a fraction, the number of children out of the total number, right? That's the fraction we start with. Then we go from that fraction to a decimal, and from a decimal to a percent. Okay, so I'll just show you how we do it then. So what we have in red, change the number into a fraction, fraction into a decimal, decimal to a percent. So we're doing the same thing for Monday and Tuesday, and remember we're dividing the number of children by the total number of people. That's where we get our fraction, change it into a decimal, change that into a percent. Then the question says, you know, which percent is highest? That's easy, right? We just need to compare the two and we can see 62.5 is higher, so Monday is higher. All right, so Monday is higher, and that one wasn't too bad. So next one here, calculate. I'll just run through this one here. 75% of 24. Now you guys remember that, of course, percent always means out of 100, so we just make that 75 divided by 100. Yeah, this one I'm just kind of giving away, right? And you know that of always means times in math, right? So we just write times below. Okay, so now we change that into a decimal, and we multiply that decimal by the number, and then we get our answer, 18. Okay, so that one was kind of more basic. and the other questions kind of go into more details. So here's another one, and again, I'm just going to run through this one. So you need to find a missing number here. 20% of some number equals 45. So first of all, I just write down, instead of a blank, I write 20% of some number equals 45. Then, instead of some number, I write n, so 20% of n equals 45. Then, I say 20% times n, because of means times in math. Then what I do is, since I can't multiply a percent times anything, I make the percent into a decimal. So now I have 0.2n equals 45. And now at this point you've got an equation that you can solve. Okay, and on the sides I'm just writing different kind of explanations for the different steps. So now we have 0.2n equals 45. We need to get rid of the 0.2. Since it's times 0.2, the opposite of times is divided. We divide both sides by 0.2. And so when we do that, we get n equals 225. So again, guys, please practice these ones. You guys have heard this before, I know. Practice them until you can get them on your own, right? Okay, so let's say we have this one here. Can you guys tell me what this would be as an equation? We're not going to actually solve the equation. But what would this be if we changed this question and made an equation out of it? Any ideas? 20 or 12% of blank equals 54. Okay, well, what we would do, oh, got a picture, I'm going to explain that in a bit. Alright, so, anyways, we would start off with the equation 0.12n, we would divide 12 by 100, right? 0.12n equals 54. And then we would just solve that equation. So I just wanted to show you that first step since it's kind of similar to the last one, right? So now there's a question here, and a picture actually. So what I wanted to explain about this guy is a guy I met, okay? And when I met him, he was 102. And if you can believe it, when he was 102, this guy still cross-country skied. And in fact, he had a ski wax named after him, which was Jackrabbit Ski Wax, because this guy was nicknamed Jackrabbit Johansson because he would, when he would ski, he looked kind of like a jackrabbit going across. Yeah, funny. He lived to 107. And when I shook his hand at 102, the guy was really, he had a strong handshake. So I was curious, have you guys ever met anyone who was 100 or more? Because my grandma lived to 100. Have you had any grandparents that lived to 100? Did he? Well, 95, that's great. That's pretty old. Yeah, and they're both around 90. That's really good. That's awesome. So the question here, it says about 14% of Canadians who are at least 100 years old live in BC. So on the 2001 census, you know, that's when they go door to door and ask people how many people live in their house. 531 people in BC said they were at least 100 years old. So about how many Canadians were at least 100 in 2001? So the first question I want to ask you guys is, can you use numbers to show the math calculation you would do in this question? Do you know what the basic calculation is you're going to do? Okay, what do you think it's going to be? All right, I shall show you. So what it's going to be, it's going to be 14% of all the people that are on the census. It was 531 people, right? So 14% of 531. So again, we just do it like we did before. We change it into a fraction, into a decimal, and we multiply the decimal by 531. Okay. So does that make sense how we got that, guys? No. Now we need your help, Rick. You're a smart guy. All right? So 14% of 531. So that was all the people in Canada was 531, and we take 14% of them. Okay, so here's a picture of a skateboarder. You guys like skateboarding? Oh yeah. It does make your head hurt when you fall, doesn't it? Okay, so we got a question here. It says a new process in a factory has increased production by 12%. Workers are now producing 30 more skateboards each day. How many skateboards did they produce each day before the new process was introduced? Okay, so the thing is, guys, it's talking about the production being increased by 12%, okay? And the amount it's increased by is 30. Okay, so I wrote down here 12% more or 30 more skateboards are how many more are produced each day after the new process is used. So we need to find out how many skateboards there were before the new process was used. So what we can say is 12% of the number we had before the process equals 30. So if we call that number before the process n, we say 12% of n equals 30. And then we just do 12 over 100 times n equals 30, 0.12 n equals 30, and then we just do the sort of solving equation steps that we did before, like we've already seen. And that's how we find n equals 250. And it kind of makes sense too, right? 250 were the number of skateboards we had before, and 12% is how much it's increased by. So it kind of makes sense that the amount of increase would be somewhere around 30, right? Since 10% is going to be 25. So it's always good to look at your questions, your answers rather, and see if they basically make sense. Okay, so here's a picture of a shirt. We got a question that says, calculate the total price including 6% tax on an $18.90 shirt. We get a red one. Do you like red? So, good. So question, what formula will we use to find the total price including tax? That's one question. And what formula are we going to use to find the amount of tax? Okay, so I'm going to show this, guys. So the formula we use, the price of the shirt before taxes plus the taxes equals the price of the shirt after taxes. Okay? So the way we find the taxes, since it's 6%, we do 0.06 times 1890. So we add this 1890 plus this amount, and we get the total amount. Okay, so is that pretty good, guys? I'm assuming it's making sense. All right, so here's another one. So Richard works at a clothing store. He's paid $150 a week plus 9% of the value of his sales for the week. Last week his sales totaled $457.85. Calculate his total earnings for the week. Okay, so we're not going to actually go through this. I just want to know if you guys can find the basic calculation we're going to start with. So what's the math we'd use to find the total earnings? Okay, so I'll show you. Total earnings equals 150, because he gets 150 each week no matter what, plus 9% of this amount here, because he gets 9% of his sales. Okay, so we're going to do that calculation, and that's our answer. Okay, Christmas early bird sale. So this one here is talking about a store offering a 10% early bird discount on a watch that regularly costs $24. What is the sale price of the watch? Okay, so what formula do we use to find the sale price? That's the price after the discount, right? Okay, so I'll show that. So price of the watch minus the discount amount. So the way we get the discount amount, it's 10%, so we multiply 0.1 times 24. So we get our sales price here. Okay, so that's what we find the sales price. That's part A. For part B, what's the total cost of the watch? So first of all, what we need to do, we need to take off the sales amount, then we add the tax, right? So that's the formula we're going to use. So the price is the sales price, which we already found in part A. Then we're going to add 7% or 0.07 times that amount, and we're going to get the total price. Okay? All right, so here's something kind of cool, guys. A picture of a Coke can, and after it's been in a freezer. You can kind of see there's a bulge here. I don't know if you guys have ever done that. Part of the reason I did that, I once left a can of Coke in my car. I shouldn't say a can of Coke. I left like a 24-pack or whatever, 12-pack in my car. And it exploded, as you guys can guess, right? And when it exploded, there was Coke all over the place. Like, I'm talking everywhere. I wasn't there when it exploded, but I saw it afterwards. And it was very sticky. Yeah, incredibly sticky. So that's just kind of talking about the fact that when a liquid freezes, it actually expands, which is kind of bizarre, right? That it would expand. Yeah? Did you shake it or anything, or was it just frozen, Rick? You had to repaint the whole room, eh? Wow. Okay, so as we know, when water freezes, or Coke, its volume increases by about 10%. So the first question we have, if we have 150 liters, what is the increase in volume if 150 liters of water freezes? Okay, so if it's increasing by 10%, what is 10% of 150? That's the first part we have to do. So we think, okay, what kind of formula are we going to do for that? What's 10% of 150? We just multiply 0.1 times 150, and we get 15 liters. Okay, so that's the amount of the increase. Part B says, what's the new volume? So all we need to do then, the volume we started with was 150. We add the increased volume of 15, and we'll get the new volume. Okay? All right. So we got that. Good stuff. Okay, here's kind of a cool question. I like this one here. It's got these things called Venn diagrams, and you'll use those later in high school. Absolutely, for sure. In fact, you're using them in grade 9. Okay, so the question says, in a survey of 100 students who brought lunches, 38 brought fruit, 82 brought a sandwich, 34 brought both fruit and a sandwich. But the question, oh, we lost Rick there. Okay. Question says, how many brought neither fruit nor a sandwich? Okay, so here's how we do this question. If we're going to find how many brought neither fruit nor a sandwich, what we do is we take the total number of the students, we subtract off the ones that brought fruit, the ones that brought a sandwich, and then we also subtract the ones that brought fruit and a sandwich. And that's going to give us the ones, oh, good stuff. Hey Rick, we lost you there, eh? Got kicked off? Okay, well hey, good to have you back. So what we do then, we take the numbers, we've got ones who brought fruit, ones who brought a sandwich, and ones that brought both fruit and a sandwich. So you can imagine that when you have the two circles that kind of overlap, then yeah, you were back pretty quick. The two circles overlap, that shows us the ones that brought both fruit and a sandwich, right? Okay, so we take the numbers that are given in the questions. It says 38 brought fruit, 82 brought a sandwich. But it says 34 brought fruit and a sandwich. So what we have to do is we have to take the 34 away from these 38, because if they brought fruit and a sandwich, we take those away, and we also have to take the 34 away from these. Okay, let's just hold on for a second. We'll see if Rick is right. So we have to take 34 away from the 82 as well, right? So when we do that, let's see what we get. Okay, so we took the 34 away from this 38. We're left with 4 that brought only fruit, 48 that brought only a sandwich, and these other 34 that are in the middle brought both. Okay? Then we add these three numbers together, and when we do, we subtract them from 100, and we find, just like Rick said, that's the number that brought neither fruit or a sandwich. So does that make sense to everybody? I like those questions. I think they're cool. Okay, so here's one. Good stuff. So here's a question. These are really cool paintings. There's a guy named Escher who made these paintings. It's really kind of cool how you get a bird changing into a fish, because the bird is just created by. Now I'm not saying the birds change into fish. Don't get me wrong here, right? It's just math, right? It's just the space between the birds produces the fish. Okay. So anyways, patterns are a big part of life, right? And so looking at these patterns here, if you look at these three figures, what would you guys say stays the same, and what would you say is changing? Okay, I'm just going to see what pink changes, or okay, or purple or whatever, and yellow doesn't change, stays the same. Okay, one more, two more on the bottom each time. That's right. Okay, so so I'll just show that in words. So what stays the same? Okay, so yellow stays the same. We have one each time. Purple changes. Purple's always 2 times the number of the object. So if this is object number 1, 1 times 2 gives us 2. This time we have object 2, 2 times 2 gives us 4, right? So that's how we get the number of purples. So the way we can say it in words, the number of squares in all are always going to equal 1, that's the yellows, plus 2 times the number of the object, or the number of the figure. Okay, so that's our equation that's going to help us find how many total objects or total squares we have for each figure number. Okay? So if the next thing says write the pattern rule using an algebraic expression, we just take these words, these English words, and we make them into like number of squares equals 1 plus 2n. Okay, so here's a question. You guys remember talking about coefficients and constants? So which one of these numbers, do you think the number 1 is the coefficient? Or do you think the number 2 is the coefficient? Yeah, you got the pattern there, good stuff. So what do you think? In an equation, the coefficient is 2. That's right, the coefficient is the number that goes in front of the variable. And the other number that's sitting on its own, that's called a constant. Right on, good stuff. So, okay, here's another one. Another sort of a pattern here. So, what do you think's changing going from one to the next? Well, okay, so first thing we need to do is complete the number of triangles. We can see, okay, there's 4 in the beginning, and we can see we're just adding one more, right? Each time, just one more. So because of that, we would just write like 6 here, 7, 8. This is a pretty easy pattern as far as looking at it, but as far as kind of saying what the formula is, it might be a little trickier. So it says describe in words the relation between the number of triangles in a figure and its figure number. Okay, so I wrote the number of triangles equals 4 plus the figure number minus 1. Okay? 4 plus, you said 4 plus n. Okay, it's going to be 4 plus the figure number minus 1. Okay? Because the thing is, you're starting off with 4 no matter what, right? So you're going to have 4 plus something. So you're basically making it plus 0 to start with. And the way you get plus 0 to start with is if the figure number is 1 and we subtract 1 from that figure number, that gives us 0. Okay? So that's how we get 4 to start with, because it's 4 plus the figure number minus 1, and since the figure number is 1, 1 minus 1 is 0. Okay? But it works for the next one as well. So if the figure number is 2, it's going to be 2 minus 1, and then we're just going to be adding that 1 to the 4. Okay? So we always just have to look at it and say, okay, how do I get what I'm looking for? You know, I've got 4 triangles, sorry. How do I get that? It's going to be 4 plus something, and if I want that something to be 0, I have to set up my equation in a way that produces 0, and this part produces 0. Okay, so then if we were writing that as an equation, it would be 4 plus n minus 1. Okay, so let's check out the next one. So the next one is just talking about evaluating expressions. So evaluating expressions is just basically plugging some number in. So where you have 3b plus 5, and if b equals 4, we just put the b in, the 4 in for the b. And now it's 3 times 4 is 12, plus 5, it's going to give us 17. Okay? So if you guys could try this one. Now this one here says evaluate the expression where d equals 4. Let's say that's b equals 4. Okay? So well, it's D for this one, but then I changed it into a B. So we're just kind of pretending that it's all the same letter so it doesn't get us too mixed up. Okay, so there, 5 times 4 minus 1, you can see the answer is 19. So who can tell me what the answer would be for this one if D equals 4? Okay, now remember, if it's equal to 4, we're going to have 4 minus 1. That's going to be our answer in the bracket. And then we're going to multiply that answer in the bracket times what's out of the bracket, which is going to give us 18. Okay, 6 times the amount in the bracket gives us 18, plus another 3 gives us 21. Good. All right. So there you go. Okay, so let's check out, here's a picture of a dog sled ride. You guys ever been on one of those? Yeah? Was that up north somewhere? Like really far north? Because my wife and my kids went on one. They went on one in Yellowknife, Inuvik. That is very far north. Yeah, my wife said it was like the coldest she's ever been. I don't know what it was, but she wore a huge parka. Just a mammoth parka, but it was still cold because of all the wind. So, okay, so here's a question that says, write an expression to represent the cost to rent a dog sled for a base fee of $35 plus $12 per hour. So what expression would you use that includes H for hours? If you're going to write like an equation or an expression, what would you write? You've got a base fee of $35 plus $12 per hour. Okay, well, what you would do, it's going to be 35 plus 12 times the number of hours. So we say that as 12H. So that's going to be our expression, right? 12H plus 35. Good stuff. All right, so that one wasn't too bad, eh? Now the next one says to graph these points in the table of values. So we have B is one of the points, and 2B minus 2. That little expression gives us these other values. And so somehow we're going to have to plot those, right? Do you guys remember talking about independent variables? Okay, you did this one, eh? Good. You remember what independent variables and dependent variables are? Okay. Well, see, this B is kind of independent, but the 2B minus 2 is dependent because it depends on whatever B is. So you could choose these values for B, 1, 2, 3, 4, and then plug them in. Okay, so you can see that 2B minus 2 depends on B, right? So this is independent, this is dependent. So remember that the independent variable always goes on the horizontal axis of the graph, and the dependent variable always goes on the vertical one. Okay, so basically all we're doing here is we're taking these values. So this is kind of like, you know, you have X and Y grid, right? Okay, so this is the point 1, 0. So you can see this is 1 to the right and 0 up, okay? And that's how we find the point. And the next point is like 2, 2. So again, it's just like 2 over and 2 up, and then we get that point. And we just join the lines. All right? So that's how we would plot the graph for this one. Now this next question here says to create a table of values. So how do we create a table of values from an equation? Well, all we do is we choose some values for the n, which is the independent variable, right? And we plug them into the equation, and we then get values for y. Okay, so we see when we plug n as 1, plug it into n plus 3, that's going to give us 1 plus 3, that gives us 4. Okay, so we're plugging in values for n into the equation, we get out these values for y. Then if the question asks us to make a graph, we could just plot these numbers here, right? These points on the graph, 1, 4, just like we did in the last question. Okay? But that's how you create a table of values. Just come up with like 1, 2, 3, 4. Those are the easiest ones to come up with. And just plug them in and see what you get out of the equation. And then you can plot your points on the graph. All right. So I think this is our last question. So this one's kind of a cool one. So it says, Joe is building a fence, and each section has 3 horizontal rails connecting 2 vertical posts. It says, write a rule for the number of rails Joe will need based on the number of posts. Yeah, I guess we are pretty well running out of it. Okay, so we're going to wrap this one up pretty quick. So we're looking for the number, a rule that tells us the number of rails based on the number of posts. Okay, so if you look at it, you say, okay, I got 2 posts, I get 3 rails for every 2 posts. When I get 3 posts, I'm going to have 6 rails. Okay, so 2 posts gives me 3. 3 posts gives me 6 rails. Okay, well, how do I make that into any kind of equation? Well, okay, so you say it's going to be 9. Okay, just hold on. We'll just do a few more steps, okay? So the way we can come up with our kind of equation is to first of all write what we have. So we know if we have 1 post, we have no rails, right? We can't have any kind of rails at all. If we have 2 posts, we're going to get 3 rails, just like we saw in the picture. 3, we're going to get 6. How many posts are we going to get, or rather, how many rails are we going to get, guys? Okay, so Rick says we're going to get 9 rails, right? Did you guys predict that as well? We're going to get 9 rails if we have 3 posts, okay? So we can see that somehow we're getting multiples of 3, right? 3, 6, 9, 12, okay? So we have to somehow set up our equation to get multiples of 3. Well, how do we get multiples of 3? We multiply like 3 times 1, 3 times 2, okay? So we've got to think about that. When we set up our equation, it's got to be 3 times something. And it turns out what it is it's the number of posts minus 1, okay? So, for instance here, if the number of posts is 2, 2 minus 1 gives us 1. We multiply that by the 3, and we get 3 rails. Okay, so Rick is saying it's 3n minus 3. Yeah, you could say it that way too, right? Because if the number of posts was n, and it was 3, I'll just write that out, 3 times n minus 1, then when we multiply that out, we do 3 times n, that gives us 3n, and 3 times minus 1 gives us minus 3, so 3n minus 3, like Rick said. Okay, so that's another way you could do this. Okay, so that's how you come up with this equation for this one. Okay, and then if it said, this question actually says to graph it and then predict what it's going to be if you have 10 posts. Well, that's a little bit tricky to do unless you have a graph that keeps going on, right? Because you've got these points plotted, but the graph keeps going on. So the easiest way to do that is just take our equation, and when we plug in the number of posts, it's going to be 10, so it's going to be 3 times 10 minus 1, and like Rick said, that's going to be 27. Okay? So guys, you've stuck in really well for this, and we've gone over a whole lot of stuff. A whole bunch of these questions will be on the test, so it's going to pay off. And I really appreciate you guys, all your participation on this. So great stuff. And so now we're at the moment of truth, guys, and we're going to guess, okay? So, who do you think Super Toad is? Super Toad is Logan? Okay, did you guys know this ahead of time? Okay, you guys are right. Super Toad is Logan. And Super Toad, you think Rick is John? Yeah, you're right. Who do you think Gecko is? Nope, Gecko's not Reese. Another guess? Good guess, huh? Drum roll. Anybody else? Rickademius. Okay. Any other guess for who Gecko is? Okay. Gecko is Joel. And what I was going to do when I was going to pair you guys up in teams, I was going to pair up Gecko and Super Toad. You guys, I was going to call you guys cold-blooded because reptiles and amphibians are both cold-blooded. And yeah. So anyways, that was cool, guys. Thanks for coming on and choosing those cool names. And I'm trying to figure out what Ricademius is. What is that? What does that mean, John? Or did you just make that up? A human-like race that has magic affinity of 1,000 times. Okay. Uh-huh. Well, it's a pretty cool sounding name. And how about Super Toad and Gecko? Why did you guys choose your name? Only if you want to tell. Okay. Like somebody was saying that geckos reminded them of the commercial on TV. I don't know if you guys have seen that for, what is that company again, where they've got a gecko always? Some sort of phone company, I think. Geico? Yeah, that's right. And mystery is Rick's reincarnation of himself. All right. Well, thanks, guys. Coca-Cola. Got to go drink some, eh? All right, well, hope you guys have an awesome rest of the Tuesday. And keep practicing these guys until you can get them all. And I know you guys will do well. All right. Well, thanks a lot, guys, and I will talk to you later. Okay, bye for now, guys.